Hi everyone, welcome to our lecture series on ordinary differential equation. We are covering the chapter called Equation of First Degree and First Order. And in the previous lecture, we have studied about variable separable. We have also taken question asked in civil services examination. Now, we are going to start with equation reducible to variable separable. If you like our videos, please share and subscribe. And if you want some clarification, if you have certain questions, you can ask to us, we will readily reply. So now we are going to continue with equation reducible to variable separable. And this one is of the format dy by dx is equal to f of ax plus by plus c. Alright. This could also be of the format, say, dy by dx is equal to f of ax plus by. So, we have to reduce this into variable separable. We can see that ax plus by plus c, we can take it as t. Ax plus by plus c is equal to t. Okay. Now, we will call this as our equation 1. If we differentiate our equation 1 with respect to x, we get here dx by dx is 1. So this is a plus, this becomes dy by dx. And this is c is constant, so derivative of constant with respect to x is 0. And this we can write as dt by dx. Alright. So, from here we can write b dy by dx is equal to dt by dx minus of a. And we will get the value of dy by dx, that is equal to 1 by b dt by dx minus of a. Now we are going to put this dy by dx into our original equation. Okay, so we will write it as one by b dt by dx minus of a is equal to f of t. So this can be further reduced as dt by dx minus of a is equal to b times f of t. So we can write it as dt by dx is equal to a plus b f of t. And now if we write dt by a plus b f of t is equal to dx and integrate this, we have actually separated the variables. Now this is with respect to t, and here we are having function as t and here x. So whatever will be given the function, we can integrate it and find a solution to this question. So this is the general understanding for our equation reducible to variable separable. Now we are going to take the first question for this session on equation reducible to variable separable. The question reads as, we have to solve this dy by dx is equal to 4x plus y plus 1 whole square, and we are given initial condition y of 0 is equal to 1. This question was asked in IFoS examination 2011 for 10 marks. Alright, so now we'll get started with our solution to this question. First and foremost, what we have learned is that we have to take our function of this one 4x plus y plus 1 as, say, t. So we will put let 4x plus y plus 1 is equal to t. So if we differentiate this equation 1 with respect to x, we get 4 plus dy by dx. One is constant, so its derivative with respect to x is 0, and this is our dt by dx. So we get our dy by dx is equal to dt by dx minus of 4. So this we can write in the original equation. So we can write this as dt by dx minus 4 is equal to 4x plus y plus 1 is t. So in this place we can write it as t square. So we write dt by dx is equal to t square plus 4. Now we have separated the variables. So this is dt by t square plus 4 is equal to b of x. Now we can integrate on the both side. So we can find the integration over here. So if we know the integration of dx by x square plus a square is equal to 1 by a tan inverse of x by a. So here it is in the standard format. So we can write it as half of tan inverse t by 2 is equal to this derivative dx is x, integral is x, and we have to add constant. We can add constant to any of the sides. So we get this half of tan inverse. In place of t we will put 4x plus y plus 1 divided by 2 is equal to x plus c. So we have got our general solution, but there are initial conditions also. So we cannot stop here. We have to find the value of this constant. We are given that when x is equal to 0, y value is 1. So we will plug this value in this one. So this becomes half of tan inverse 4 into 0 plus y is 1. So 1 plus 1 is 2 divided by 2 is equal to x is 0. So we get our c as half times tan of 2 by 2, that is 1. So we know that the value of tan inverse 1 is pi by 4. So we got our value of c as pi by 8. So we can write over here the value as half of tan inverse 4x plus y plus 2 divided by 2 is equal to x plus pi by 8. Okay, so if we send this 2 on right hand side, what we will get? We will get tan inverse of 4x plus y plus 2 divided by 2 is equal to, we are sending it on the right hand side. So this becomes 2x plus pi by 4. Okay, so this nearly gives our answer, and we can further simplify it as, if we take tan inverse on that side, that becomes 4x plus y plus 1 divided by 2 is equal to tan 2x plus pi by 4. And if we send this from this side to here, this becomes 2 times. So we get our answer as 4x plus y plus 1 is equal to 2 times tan inverse 2x plus pi by 4. So this is our answer. And this question is normally asked, such kind of question asked in compulsory question. Now I am going to take the second question. Now this is the second question that we are taking for this session. That question reads as dy by dx is equal to sine of x plus y plus cos of x plus y. This question was asked in IAS examination 2013. Now it is very clear that we have to do it by reducing it to the variable separable. So we can see x plus y and x plus y are occurring in both these functions, sine and cos. So first step is that we will take let x plus y is equal to t. This is as equation 1. If I differentiate equation 1 with respect to x, we get dx by dx is 1 plus dy by dx is equal to dt by dx. So now I will put the value of dy by dx over here. So this becomes dt by dx minus 1. This is the value of dy by dx. And in place here in the RHS we can write as sine of t plus cos of t. Okay. So we have put the substitution. Now we will send this minus 1 on RHS. So this becomes dt by dx is equal to 1 plus cos of t plus sine of t. So we have to find this equation, differential equation. So we will first separate the variables. So this becomes dt by 1 plus sine of t plus cos of t is equal to dx, and we will integrate on both sides. Now we have to find this integral. Now differential equation, all the time it boils down to the fact that how good you are at integration. So I am going to integrate this. This integration says we have to integrate dt by 1 plus cos t plus sin t is equal to d of x. Now here what will come to our rescue is our trigonometric identities. We have to recall some of the trigonometric identities. We have studied cos 1 plus cos t is equal to 2 cos square t by 2. On the similar lines, if you recall trigonometric formula, sin t can be written as 2 times sin t by 2 cos t by 2. We are going to use it, but it could also be done by other methods. So that is the case with integration. You can put any substitution. The formats will be of the same kind. So we can write this as 2 times cos square t by 2 plus 2 times sin t by 2 cos t by 2 is equal to integral of dx. Now you can see here 2 and cos t by t is common over here. We can take that also, but if we take the whole as common, then this can be written as 2 cos square t by 2 plus 1 plus cos is taken 1, so 1 cos will go in denominator, so sin t by 2 by cos 2 by 2 is your tan t by 2, and this is equal to dx. Okay, so if we send in numerator, so this becomes a half of sec square t by 2 divided by 1 plus tan t by 2 dt is equal to d of x. Okay, so we will find this integration. Now we can see in this integration one thing, that this is the derivative of the denominator. That is, if we put 1 plus tan t by 2 is equal to say u, then we can take the differentiation. This becomes sec square t by 2, and we have to take the differentiation of this argument also, that is half, this is dt is equal to du. So this whole thing is your du. So this is du divided by 1 plus tan t by 2 is taken as u. So we got our answer. And the integration of du by u is log of u is equal to x plus c. Now we will keep reverting back the values. We know the value of, what is our value of u? 1 plus tan t by 2. Okay, so we can write it as 1 plus tan t by 2. We also know the value of t, x plus y. So this gives our answer. So this requires substitutions and further substitution and back substitution. So this is our answer, and this questions kind of question keep coming. So this is the basic ingredients of this chapter on reduction for variable separation. So thank you for watching. Please like, share and subscribe. If you have any doubt with regard to any question that is being solved on this platform, please comment. We will try to find solution to your problems. Thanks you once more.